The purpose of this video is to help you calculate z-scores and using the z-score table. The standard normal distribution has three important properties to remember. The first property is the area under the curve is equal to 1. The second property has a mean equal to 0. And the third property has a standard deviation equal to 1. The z-score formula. The z-score measures how many standard deviations a single data item is from the mean. X is the value minus x bar, which is the mean, divided by s, which is the standard deviation. Here is the positive z-score table with the positive z-score to the left and the areas under the normal curve to the right. Here is the negative z-score table with the negative z-score to the left and the area under the normal curve to the right. Remember, if the probability that the z-score is between A and B, we must subtract A and B to find the z-score. If the probability is greater than or right, we subtract the z-score and 1. And if the probability is less than or to the left, we use the exact z-score. And we must convert to percent when asked for probability or percent. In this example, find the indicated z-score of 1.42. We use the positive z-score table to find 1.4 and move to the right until we reach 0.02. The z-score is 0.9222. In this example, find the indicated z-score negative 0.42. We use the negative z-score table to find negative 0.4 and move to the right until we see 0.02. Then we minus 1 from 0.3372 to get the z-score of 0.6628. Here are two values of negative 1.75 and 2.05. First, we find the z-score for the negative 1.75 on the negative z-table, which is 0.0401. Then we find the positive z-score of 2.05, which is 0.9798. We subtract both z-scores to get a z-score of 0.9397. Now we look at the critical values for the standard normal distribution. The critical value is a z-score separating unlikely value from those that are likely to occur. For example, z 0.35, we minus 1 from 0.35, we get 0.65. Next, we use the positive z-score table to find 0.65 to get a z-score of 0.7422 or 74.22%. In conclusion, the logic of z-scores underlines many statistical tests. First, scores are normally distributed around their mean. Second, sample means are normally distributed around the population mean. And third, differences between sample means are normally distributed around 0 or no difference. We can exploit these statistical tests to help us decide whether or not an observed difference between sample means is due to change. Thank you for listening, and I hope this video simplifies calculating z-scores and using the z-score tables.